Now, so we're done with, we didn't do salt analysis. Salt analysis is the test for salts. We're gonna skip, we're gonna skip all questions where, remember, all chemistry is interconnected, so we'll just focus on acid bases salts questions directly. Okay. So for example, you've got this question, he says, what is the question saying? Why water is behaving, so the question says, why is water behaving as an acid in this reaction? First thing, you look at water. First thing, what is an acid? What was the definition of what an acid was? Acid was
Donor
a
of H plus ions.
the proton donor, right? Proton, which is H plus one. So it was a proton donor, right? So is water doing that in the reaction? Okay, water tha, and on the other side, the water does not have the H plus one. So that means, okay, while this happened, the water lost a proton, right? It lost an H plus one. So the answer is that it's acting as a proton donor. It loses an H plus one ion. Is this clear? So the other thing, given aqueous solutions of ethylamine, which is this one, and sodium hydroxide, describe how could you show that ethylamine is a weak base like ammonia and not a strong base like sodium hydroxide. So although we did do this, but how do you know whether how do you differentiate between a weak base and a strong base? You have weak acid and a strong acid. It's when I was looking at one thing.
So the strong will be completely dissociated.
Weak base. What's a weak base? It partially ionizes or dissociates and produces or
So
accepts
ionizes and dissociates is the same property, right?
same thing. Okay. So partially ionizes and accepts fewer H plus one ions. Or strong base it fully ionizes and accepts more H plus accepts more a higher number of H plus one ions. But anyways, he's not asking for the definition over here. Wait, Kara, how could you show that one of them is a strong acid and the other one is a weak acid, or a strong base and a strong? I don't. We did indicators. Let me just open the notes once more. कि हाँ, एक से मैं notes खोल लूँ. Remember we did indicators. पता नहीं, I remember. I do remember getting formulas and equations. But I think we missed out on the universal indicator. Just one second. कहाँ पे the indicators and the color changes? We did that.
So pH scale से पहले.
हाँ, मतलब pH scale किया था ना. We did indicators. ये था नहीं. Equations से पहले था, equations के बाद था. Just one second. ये. अच्छा, we did indicators. अच्छा, main indicator तो इसमें रह गया, which is अच्छा, we did litmus paper with red and blue, right? We did methyl orange, we did phenolphthalein. In acid, it's going to be colorless. In alkali, it's going to be pink. Thymophthalene, we did that, right? So the one that we missed out, so I'm just going to add that at the end. There's one very important one. Okay, they're going to ask you, we did weak acids, weak bases as well. But there was one very important indicator that we missed out on, and that was the universal indicator. The purpose of the universal indicator, it's not used in titration, it's only used to. Nabila, इसमें Google Classroom में upload हो जाएंगे, but I'll make sure today I'll send it in the group as well. Plus all the video lectures as well. As a universal indicator. The first purpose of the universal indicator is that it helps you differentiate between weak. So it differentiates between weak and strong acids and bases. You remember, it's not to be used in titration. वो जो previous थे ना, they were all being used in titration. This is not to be used. These are not to be used in titration. You can remember that. Keep that in mind. Now,
मतलब
what the
बाकी में यूज कर सकते हैं, मतलब टाइट्रेशन को छोड़ के,
किसमें
लाइक जो बाकी थे आयोनिक प्रेसिपिटेशन वगैरह।
उसको तो इंडिकेटर चाहिए नहीं था ना.
हाँ बस सही है, टाइट्रेशन में ही चलेगा।
आयनिक प्रेसिपिटेशन में दो मिक्स करते थे, वो सॉल्ट बन जाती थी, insoluble, right? And you would just filter it out. ठीक है, so you only needed an indicator in titration. अच्छा, तो 7, 14 and 1, 0. अच्छा, so this is strong acid. Over here, somewhere close to 7, it's going to be a weak acid. So this is going to be a weak, what? Weak base. And this one is going to be, but the closer it is to 14, it's going to be a strong base. And in the middle, it's going to be neutral. So the middle part would be pH 7. That means it's going to be neutral. Now the colors would be, it's going to be green over here. It's going to be blue if it's a weak base, and it's going to be purple if it's a strong base. And if it's a weak acid, it's going to be orange, and if it's a strong acid, it's going to be red. So this is how the color would change. Okay, so red, orange, that's weak acid, strong acid. Blue, purple, that's a weak base, strong base, and green is in the middle. So I'm going to go back to the question. So remember, this was an important point that a universal indicator helps you. So how would you show that it's a weak base? So first thing, you will add a universal indicator. अच्छा, paper भी होता है, solution भी होता है. It's both. ठीक है, like litmus paper, litmus solution. So add, let's say, a few drops of universal indicator solution. Now you're going to tell them that if it's blue, well, the points will like that. So write the whole sentence. If it is blue, that means it's going to be a weak base. And if it comes out to be purple or indigo, that means it's a strong base. Yeah, that's how you're going to show. So remember how to always try to interpret the question properly. This was not actually required. They weren't asking for the definition. They were asking you to, how would you show it? Okay, it's a weak base and the other one is a strong base. Okay, so or usme he's told us that so NaOH over here would give you, because they told us NaOH is a strong base, and they told us it's a weak base like ammonia. So ethylamine is a weak base. So in your sentence, you're going to write a point that is that since ethylamine is a weak base, it will turn blue. And in the case of NaOH, which is a strong base, it will turn purple. Okay? Is this clear? Now, moving to the next one. Moving to the next one. The next one is slightly even trickier. So for the next one, he says ethylamine like ammonia. Okay? When you get a question like ammonia, okay, it reacts with acids to form salts. The first thing is you have to go back and you have to revise two things. Okay, the reactions. We're going to go back to the reactions. because he's saying like ammonia, right? This may, if I go back, there was a reaction of ammonia. तो ये बहुत ज्यादा चीज है इसमें salt में एक second. I think it was नहीं, salt preparation. ये उधर ये वाला. अच्छा, like ammonia, ठीक है. Remember, we did 4 reactions. There were 4 bases: oxides, hydroxides, uh, ammonia was a base, and carbonates were basic. अच्छा, so ammonia over here is a base. ठीक है, that is NH3. What happens to NH3 is कि NH3 goes and accepts, because it's a base, it accepts NH plus 1 coming from the acid. And what happens to it? It becomes NH4 plus 1, right? So all these NH3s, they will, because they're basic, they will accept H plus 1 ions. And when they accept H plus 1 ions, they become NH4 plus 1, right? So now going back to the question. The question is, he says ethylamine like ammonia, right? It's doing exactly the same thing, which is, okay, this is your ethylamine. Ammonia did exactly the same thing. If I had ammonia reacting with HCl, what would happen? It would form, it will accept, the ammonia will accept an H coming from the HCl. It will add it to itself, and Cl minus 1 would be left. So that's your ammonium salt, right? Ethylamine does exactly the same. It accepts the H coming from the acid, and it becomes CH3, CH2, NH3 plus 1, right? So it's doing exactly the same. Now, what he's saying is in the question, how could you displace ethylamine from the salt? So the salt is now formed. Now what he wants is he wants the ethylamine back. He's saying, how would you go back? He gets the, if you have NH4 plus 1, how do you go back? That's a pretty simple question. You added an acid, right? The acid gave it the H plus 1 and it became the salt, right? Now you want to extract the H plus 1 back again. So who's capable of pulling the H plus 1 back away from it? Okay? What you want is, you have CH3, CH2, NH3 plus 1. It has already formed the salt. Now you want to remove the H plus 1. So who removes the H plus 1? A base is going to remove the H plus 1. For example, NaOH, right? Because the OH ions are capable of pulling the H plus 1 out of the salt. So you added the acid, and the acid gave it an H plus 1. Now you want the H plus 1 back. So what you're going to do is you're going to add a base to it. And what would the base do? Because it's OH ions are basic, they'll extract the H plus 1 back again. We did this reaction as well. We did this reaction right at the end. And that reaction was, जिसका तो वो fertilizer wala, we did a reaction right at the end. That reaction was exactly the same. It was this one. If you have ammonium, you add a base to it, and the H plus 1 is going to be pulled back or pulled out or accepted by the base OH. The OH will accept the H coming from there, and it will form water. The NH4 will turn back into NH3, and whatever is left, that's your salt. Okay? So try and understand the question. Okay, this one was a tricky one. Most people in the exam would probably not be able to do that. Okay, so I'm just going to simplify this. You added an acid, the acid gave it an H plus 1, which is why there was an extra H over here. You want the H plus 1 back. You want to remove the H plus 1, so you add a base to it. The purpose of the base is to accept the H plus 1. So if you add a base to it, the OH will turn into water. This will lose the it will lose the H, right? And whatever is left, that's your salt. So it's going to be NaCl. You don't have to write the equation. That's not important. All they were asking was suggest how you could displace ethylamine. So 1 mark would have been, you just had to, this is 1 mark, you would have written NaOH. Sorry, मेरा वो disconnect हो गया एक second पहला. So, but is this part clear? So so basically coming back to this, you'll get 1 mark for writing the base, and there's going to be 1 mark for stating that NaOH is going to accept DH plus 1. Okay, is this clear? Nabila here, Shanta, is this clear? Moving to the next one. He says that there's silicon 4 oxide SiO2 and zirconium oxide, which is ZrO2, are both macromolecules. They have similar physical properties, but silicon 4 oxide is acidic, so there's an acidic oxide, and zirconium 4 oxide is amphoteric. Remember, we did acidic oxides, amphoteric oxides. The first thing is define the term macromolecule, which is from chemical bonding. What's a macromolecule? It's a very large molecule. Molecule with many covalent bonds forming a giant covalent structure. And then actually, while you're answering this, remember the term molecule. Basically, the term molecule, whenever the word molecule is used, if you're defining it, you're going to get 1 mark for writing covalent. Okay? The word molecule is only reserved for covalent, something that's forming covalent bonds. Macro means very large or a giant structure. So basically, the two keywords would have been giant and covalent, right? They would be looking for that. It's a giant structure, and it's got covalent bonds. As I predict 3 physical properties of these two oxides, again, that's a chemical bonding question, but we'll do that. If you have a giant covalent structure, it's going to have very high melting and boiling points. It's since it's a macromolecule, it's a covalent molecule. There's not going to be no electricity conduction. And like diamond, because there's so many bonds, it's very hard to break it. It's going to be strong. It's not going to dissolve, does not dissolve in water. Because to dissolve, it has to dissociate and disintegrate into smaller pieces. Well, if the bonds are really strong, and it's a giant structure, that's not going to happen. Name an element that has the same physical property. Now, the only macromolecule or giant covalent structure that you've studied, that's diamond, right? Uh, there's diamond, there's silicon oxide, which you've also studied. And when we were doing chemical bonding, I told you there's another one which is graphite, but I told you that silicon oxide and diamond have very similar structures and very similar properties. Okay, I'm just going to revise chemical bonding very quickly. Diamond was a carbon atom bonded to four other carbon atoms, which were again then bonded to carbon atoms, right? And it just went on. It was a tetrahedral structure. It was a giant structure. Silicon oxide had exactly the same structure. One silicon bonded to four oxygens. Silicon makes it's group four, so it makes four bonds. Oxygen is group six, so it makes two bonds. So if there's another silicon, then that silicon is again bonded to four oxygen atoms, right? And so on. It just went on endlessly. So diamond and silicon oxide had very similar properties. So name a reagent that reacts with the oxides of both elements. You get both of them. So remember, if something is acidic, that means it will only react with a base. If something is acidic, if something is amphoteric, that means it reacts with what? It reacts with base and with acid. It's going to react with both of them. So the question was, find a substance that reacts with both of them. So that's going to be a base because the base reacts with the acidic silicon oxide. The base also reacts with the amphoteric one as well. Because I'm just going to repeat it again. The first oxide was acidic. Acidic things, they only react with bases. The other oxide was amphoteric. That means it reacts with both acids and bases. So the common thing between the two is they're both going to react with a base. So you can think of anyways that's the most common base. ठीक है? Oxides, कौन-कौन सी bases थी? You've got oxides, you've got hydroxides, you've got carbonates, and you've got ammonia. There were four bases. So we're going to go with sodium hydroxide. And then he says, name a reagent that only reacts with just one of the oxides. So if it's one of the oxides, so that's going to be an acid because the acid will react with the amphoteric one, but it will not react with the acidic one. The acidic is not going to react with an acid. So the other reagent, which is zirconium 4 oxide, question ke, the reagent, it's you can think of HCl, and the oxide that reacts with it, that's the amphoteric one. That's zirconium 4 oxide. Okay, that's zirconium 4 oxide. Okay, is ये clear है? Is this clear? Yeah, is this clear? Abhiya Shahzad Rani, is this clear? ये चीज clear है? Moving to the next one. Okay, this one is it's mostly about metals, so I'm going to skip this one. Tests on says we didn't do that yet. Yeah, again, he says 2 marks question. How do you prove something is amphoteric? Well, step number one, uh, react it with acid. I mean, react M, the white powder, with acid. Second step, I mean, name the acid as well. Let's say it's here. If it's amphoteric, it would react with both of them. React it with base. Let's take NaOH. So how would you know it's amphoteric? If M, the white powder, dissolves in both of them. Dissolves and reacts with both of them. Then it is Amphoteric. Okay, then it is amphoteric. Now, so then it is amphoteric. I said next one. This was about ionic equation. He's asking you to write the ionic equation. So the question is complete the following ionic equation, or इसमें what you have is you're given as what did I tell you about writing ionic equation? I told you that anything that is aqueous, it will dissociate into its ions. The ions will get scattered in water. So calcium carbonate is a solid, so its ions will stay together. HCl is aqueous, so what happens to it? It dissociates into its ions. Calcium chloride is aqueous. Calcium is group 2, so it's +2, and there are 2 Cl ions. So it will also dissociate, and there's carbon dioxide gas, and there's water, which is liquid, right? So what's going on is that, again, reminder, anything that is aqueous will dissociate into its ions. You're going to write the ions separately. They're going to mix in water, and they will ionize. They will become separate. And then you remove the spectator ions. The spectator ions that you have, it's, I think, Cl ions. Spectator ions are the ones that did not undergo any change. All the other ones, they underwent change. I mean, there was H, and now there's water, right? And so on. So your ionic equation is going to be in the product, it's going to be calcium +2 aqueous. And there's going to be CO2 gas. And there's going to be H2O, which is going to be liquid. Achha, define the term. What's a base? A base is a proton acceptor. But you're going to write the full sentence. A base is a proton acceptor. Okay, this is just the keyword that you're going to write. Given aqueous solutions of ammonia and sodium hydroxide both having a constant, how could you show that ammonia is the weaker base? Again, the question is about a strong base and a weak base. How would you show that ammonia is a weak base? And you have to show it, right? You don't have to describe it, or you don't have to, you have to show it. So you're going to use a universal indicator paper or indicator solution. So you're going to state that if you add ammonia to it, if you add universal indicator solution to ammonia, which is a weak base, what would be the color? The color would be blue. And if you add it to sodium hydroxide, any which aqueous, which happens to be a strong base, so what would happen to it? It's going to be purple in color because it's a strong base. Okay, so just write sentences, okay, describing these key points. That's the next one. The next one is that they've said that there's a thing called hydrazine, and it's a weak base. So what effect would hydrazine have on the pH of water? So the first question is, what is the pH of water? Water is, remember, it's neutral, so the pH of water is 7, right? So the second point is, if you add a weak base to it, what happens? What's the pH of a weak base? A weak base would have a pH of 8 or 9, right? 14 would be a strong base. So if you add a weak base to water, right? So what will happen to the pH? It will go up, or it will slightly go up. That's just the one mark. So if you add hydrogen, the pH of water, it's going to slightly increase. Give a reason other than pH why hydrogen reduces the rate of rusting. Oh, hell, uh, that's a totally different chapter. We'll do that in metals. But I think There's a titration question. Most का तो नहीं है. अच्छा, so you got this one. Now he says that there's a burette that's filled with HCl. Now that's your acid. And there is a flask which has lithium hydroxide. Lithium is group 1, so it's Li plus 1, OH is minus 1, so LiOH. So the lithium is going to fall into the flask, and all the particles of lithium hydroxide would eventually get neutralized. The HCl is going to come, it's going to react with lithium hydroxide. What will form? The OH and H will combine to form water, and the salt will be lithium chloride, just like NaCl. So eventually, as the HCl is poured, all the lithium that you have in the flask would eventually get used up, and that's when you turn off the tap. So he says a few drops of indicator are added, and dilute HCl is added slowly, until the indicator just changes color. The volume of the acid needed to neutralize the lithium hydroxide is noted. A neutral solution of lithium chloride, which still contains the indicator, is left. Describe how you could obtain a neutral solution of lithium chloride which does not contain the indicator. So the problem now is you've got the neutral solution. You've added the exact right amount of HCl, so there's no excess HCl. But the trouble is that the indicator is still present. So titration, if you remember titration, what was done? There were two things done. Number one, how do you remove the indicator during titration? The first one was you add charcoal, which absorbs the indicator. And then what you do is you filter out the charcoal. That was the first thing. There was another thing which he's doing over here, which is that once you're done with the reaction and the indicator has told you that this is the right amount, I mean the indicator would change color and it will tell you this is the exact, let's say it's 21 or 20.1 cm3 of HCl that was poured in, and you noted down the volume, right? Once you know the exact amount of HCl that is supposed to be poured into the flask, what you're going to do is you're going to repeat the reaction. So that's point number one. You can just use the charcoal to remove the indicator. But since he noted down the volumes, you repeat the titration again without the indicator. You give without the indicator and use the noted volumes, because now you know, okay, what volume is supposed to be added, right? So use the noted volumes from the earlier titration. So I think in this question, he was looking for the second answer because he already noted down the volume. So there were two ways of removing the indicator from the titration. Acha, Agla, you cannot prepare. Acha, now remember, titration was used. If you remember salt analysis, titration was used if all your reactants and products were soluble. Group 1 salts are soluble. Lithium is group 1. Acids are soluble. Water is a liquid, right? So if all of them are soluble, you use titration. Now in the next part, you think magnesium chloride cannot be prepared by this method. Describe how you could prepare a neutral solution of magnesium chloride. So you want to prepare magnesium chloride. There are 3-4 reactions that you could do. If you want to prepare magnesium chloride, you're going to use the acid which is you're going to use the acid which is HCl. How do we know it's HCl? Because it's obvious it's got Cl in it, so it's going to be HCl. And there were 4 things that could have been added over here. You could have added Mg, so that will produce metal plus acid produces H2 gas. You could have used oxide or hydroxide, and that would produce salt and water. Or the third thing was you could have used carbonate as well. In that case, it will produce water and carbon dioxide, right? So I'm just going to go with the metal. Again, the reason you can't use titration over here, you have to use a different method, is magnesium is a solid and HCl is aqueous. So the method that was going to be used over here was excess method. Excess method is when you have a soluble salt and the reactant that you're using is an insoluble reactant. So what you're going to do is you're going to add excess of magnesium. You're going to add a lot of magnesium until all the acid is used up and is converted into the salt. So you keep adding magnesium to the flask. You want to get rid of all last molecules of HCl and convert them into the salt. Once all the salt has been produced, the magnesium excess solid is filtered out. So add excess Mg to HCl, aqueous, keep adding until no more bubbles of H2 are seen. Then what? Remove the excess Mg by filtration. Now your solution would only have the salt. That is the only thing that's going to be present. And he didn't ask for crystallization because he just wanted a solution of magnesium chloride. So you're going to stop over here because the last part would have been crystallization, which we're not going to go into. Okay. So, we'll continue tomorrow. Okay, we'll do some more past paper questions. We'll do past paper questions on the weekend as well. I'm sharing the notes now. You can remember this is the most important topic in chemistry. This is the only difficult topic in chemistry. Okay? You you get this done, revise this as much as possible. The rest of chemistry is going to be relatively very, very easy. It's going to be this is the only difficult thing. Okay? So let's continue tomorrow then. Okay, everyone, take care.